Good afternoon, everyone. It's not audible, no? What is there? Good afternoon, everyone. It's not audible. শোনা যাচ্ছে না, sir. Good afternoon, everyone. Please, can we have your attention? Good afternoon. It's not audible. What is this? No, my volume is fine. Please, can we have your attention? What is going on, Megha? Please, can we have your attention at the back? Please, can we have your attention? দুটোতেই বলবো কি করে এরকম ভাবে রেখে Please, can we have your attention, please? Can we have your attention, please? Good afternoon. Please, can we have your attention?
Banerjee, please.
Good afternoon, everyone. Can we please have your attention? I just wanted to inform you that we will be starting our session very soon. So please, if you would remain seated, it would be very nice. Thank you. Huh? What? No. Where is this thing gone? There was something here. Where is it? He has come, my God. Chalo, finally. এরকম ভাবে just checking if the mic works. Yeah, it's fine. Thank you for your patience. Thank you for bearing with us. We request you to please take your seats because we will be beginning the session now. So if you would please take your seats, it would be very appreciated. Thank you very much. Very good afternoon to our respected teachers, the distinguished speakers, the President, Secretary, and the Treasurer of the Alumni Association of the Department of Chemical Technology, and of course, our beloved alumni, the dear students and research scholars. On behalf of the Alumni Association, I would like to extend a very warm welcome to all of you to this half-day seminar, which is the first seminar that is being organized by the association in the 22 to 23 session. And we believe that this initiative will create a strong foothold for our next big venture, namely our reunion, which is going to be held in the month of January next year. So I would now like to request our respected head of the department, Dr. Mohua Ghosh, and the President of the Alumni Association of the Department of Chemical Technology, Mr. Shochi Dulal Mojumdar, to please take their respective seats on the dais. Sorry, ma'am. Thank you very much. I would now like to request our head of the department, Dr. Mohua Ghosh, to please deliver the welcome address to the participants. Ma'am, if you please.
Good afternoon, everyone. It's really a pleasure for me, and as an alumni, as a head, and the faculty of this department, to see you, all of you, in this first program of Alumni Association. But I must congratulate our team, my students, my faculties, junior faculties, to make it happen. And obviously our president had taken a great initiative to make it happen. So I really have a great joy to have all of you with us today. And I wish this is the initiation, and we will go for the propagation day by day, and we will flourish in many ways so that we can have a beautiful and organized Chemical Technology Alumni Association, which is very much required in nowadays to grow up as a department for our better future for our students and also for our worldwide fame. So I would request all of you to take this responsibility to move forward of this association, and I hope you all will do. Especially to our students, for the students and scholars, this responsibility is all yours. So we will we have a great faith on you that we will carry out this beautiful responsibility with utmost care and hard work. So this I welcome you all. Nothing else. I not to take much more time. Already we are late. So welcome you all for the departmental program, our alumni association. I hope we will meet again in the not in every month or every quarter of the year. Okay. Thank you. Thank you very much.
Thank you, ma'am, for the motivation and encouragement. I would now like to request the President of the Alumni Association, Mr. Shochi Dulal Mojumdar, to address the alumni and the students. Sir, if you please.
Good afternoon, everybody. Actually, before going for the little deliberation, I should give my introduction because the young students, alumnus may not be knowing me. I am basically 1971 MTech from this particular institution. And fortunately, today where you standing here, this particular hall, that is that Dr. Bose Auditorium, I was quite fortunate to get his association. He was our teacher that way. So today I am here and can still remember his day-to-day class sessions, and that's a very interesting and nostalgic to me because I am here today. I, on behalf of myself and of course of my Alumni Association, all members, I welcome you all in this particular program. I especially welcome our speakers, esteemed speakers, Mr. Banerjee and Dr. Maithi, and of course Tripathi, Dr. Tripathi, and Dr. Tripathi and the session chairman, our esteemed, very senior, respected Dr. Mujumdar, because we stayed together in Technology Hall. He must be remembering a little bit, but I remember him very well. So we are really privileged to be here today to get the association of these three esteemed people. Actually, last 2.5 years, it was quite bad, you all know, because of the COVID. We could not do much, but brighter days have come little bit, and presuming that our group, I mean under the able guidance of Dr. Roy here, sitting there, and our other senior colleagues, with the thought of reactivating the activities of this association. Our theme was, in this program, 3 things. One is that to reinforce that website. So website was there for a long time, but it was not that active that time, during especially the COVID period. So we thought of taking the help of all the students to reactivate that website and enroll as maximum number of students or alumnus in this in the roster. Fortunately, by their efforts, we could gather about 130 alumnus enrollment, and it's not small, but still it will increase day by day. Besides that, we thought of going for some technical sessions, which we are having fortunately today, and this is the first of its kind. But the theme of that, it is not exactly for understanding the technical things because the subjects are different, but we can get the taste of the subject, whatever maybe it may not fall in our line with all the students, but it basically to give a contacts and interactions with the seniors. This chance normally doesn't come until unless we do some type of this type of exercise, like a workshop or seminar or something like that. In this gathering, we could get a chance to interact with our seniors who are in the field for a long time, and this will also help in the career path and the career growth of the young students and the alumnus. So this was also a theme of our activation of this program. And thirdly, and most important thing, we thought of to increase the contact between us, between the alumnus and between the students. We should have some social gatherings. Through the social gatherings, quite easily we can approach each other. And we have got a number of talents in our alumnus and the students. Either they are rich in culture or other fields also. So we thought of that, take the help of those and organize some cultural programs, at least once in a year or twice in a year, so that if everybody can come in there and participate in that program, along with their even the spouse and children, so that the interaction between the total member of the association is increased. So fortunately, we are going to organize a sort of a cultural program in the month of September, I think. And our team is already working on that, and they are giving a very good effort to organize that. And we should also cooperate from heart to all the students. Lastly, I can say only one small message, only two words: maintain contacts. Maintain contacts. The program which we normally do like this, in particular that day we are always very much enthusiastic, but the day we leave, we normally forget. So this contact should be there and it should be maintained, and communication channel should be enhanced very much, so that through that we can know each other quite frequently, quite different occasions, and that will help to for the growth of this total alumni association. With these few words, I'll end here itself, and the next session will be now chaired by Dr. Majumdar. I will invite Dr. Majumdar to come to the dais and take the charge. Dr. Majumdar, please.
Thank you, sir, for these important perspectives. We hope to work along these lines in the future. I request Megha to please bring the bouquet. The President of the Alumni Association will now felicitate our Honorable Chairman. I request the Chairman to welcome our first speaker of the day to the dais.
Good afternoon, boys and girls, and ladies and gentlemen. It is really a happy moment for me to be here. Hello. It is really a happy moment for me to be here to chair this occasion organized by the Alumni Association. It is happy particularly because all the speakers and the head of the department and the functionaries here present are almost my students, barring one or two. So this is really very happy, and so to say, I am speaking to grandchildren, the students there behind me, behind you. Now I won't take much time because there are two speakers, very distinguished and accomplished in their own fields. Both of them happens to be our students. So it is yet another very happy occasion. Now, the first speaker, I am just giving you the curriculum vitae academic of the two speakers very briefly. The first speaker is Mr. Devgan Banerjee. He definitely graduated from this college and university. Oil technology was the specialization, and M.Tech in oil technology from the same university. He was with Oil India Limited and retired as executive director, and has got more than 34 years of experience in drilling and production of crude oil and natural gas. You can just imagine the experience he has. Mr. Banerjee has been the chief managing director of Inform Global Private Limited at Kolkata and senior technical advisor of Kalish Private Limited at Ahmedabad. He also served as chief managing director of Duganto Oil and Natural Gas Private Limited, Mumbai. He was an empaneled faculty of ICED Jaipur for CAG under the Government of India. Mr. Banerjee is also a regular faculty for the CMA chapter of Duliajan Assam for intermediate paper for operation management and strategic management. Mr. Banerjee will speak on a topic entitled Organizational Culture and Behavior. Now about the speaker number 2, Dr. Himanshu Shekhart Tripathi, happens to be very close to us because I was technically associated with the ceramic engineering section of this department. He is Senior Principal Scientist and Head, Refractory and Traditional Ceramics Division, CSIR, Central Glass and Ceramic Research Institute. Scientist in Charge, CSIR, CGCRI, Khurja Center, graduated from the University of Calcutta and also did his M.Tech from this university. He also completed his PhD Tech degree in ceramic engineering from Calcutta University. He worked for 2 years as postdoctoral fellow at Boston University, Massachusetts, USA, and 4 months as academic visitor at Imperial College, London. Dr. Tripathi has about 25 years of research experience in different fields of ceramics. He has received many fellowships and awards like Refractory Technologists Award from Indian Ceramic Society, Ghanshyam Mishra Innovation Award from All India Pottery Manufacturers Association, Devkaran Award for the from the Indian Ceramic Society. He published more than 55 research papers in SCI journals. More than 35 papers were presented in conferences published in their proceedings, and 6 patents he has got to his credit. He was president of the Indian Institute of Ceramics for 2021-22, associate editor of International Journal of Applied Ceramic Technology, and reviewers of many reputed international journals. Mr. Tripathi will speak on corrosion behavior, particularly by glass, I think, of alumina refractory, chrome alumina refractories. So welcome to the speakers. I would prefer to sit below because I cannot hear properly by sitting over the dais. So thank you and wishing the speakers a very good time. I am sitting below.
Thank you, sir. I would like to request our chairman to welcome our first speaker to the dais and for the felicitation and the lecture. Megha, if you would please. I would like to request our chairman to please welcome our first speaker to the dais for the felicitation ceremony. Thank you very much, sir. Our first speaker will now deliver the first lecture of the day. Sir, the stage is yours. Thank you.
First of all, the sound system is not very comfortable. So what I prefer is that I put it down. Am I audible? Oh, sorry. Then I need to rearrange it because it is not giving the proper audio there. Because without audio, I am not going to perform anything on the video. I will be just speaking. Is it now okay? Thank you very much. So, just I am opening my, a small presentation is there, not to guide you, but to guide me. And regarding the subject, first of all, why I am standing here? Why I am standing here? Because maybe the first one, I am an alumni. I am a part of the association now. But secondly, I may not be a because of my achievement or I reach some level, I am heading some of the companies, I am giving some advice or support. I don't think that is not the correct thing that I am standing here. I am standing here, what I believe is that whatever which I have realized over the 34 years of career and about 3 years of BTech doing here, that you must believe I am not giving you gyan, because whatever I did with love, affection and dedication. I never looked back or looked at the advance that what I want to achieve. Though there are a lot of topics, they say that you must plan your goal, the target, the steps should be small, it should be visible. But I feel whatever you got it, and you should do it with good attitude, good attachment, otherwise don't do it. Do something which you like it. So that where it becomes, bring us to a point where it says the organizational culture. Because every time in the Alumni Association or whenever we meet the old boys and the new boys, I'm saying boys, but it must be the person, is gender neutral. So that time, this is in our old days we used to do this, in your new days you are not doing this. This type of comparison always comes into mind. I'm saying the days remain the same, it is the same 24 hours, it is the same sun, it is the same moon. But the attitude has changed. What has changed? The attitude has changed. That attitude, why it has changed? Because the culture has changed. Now that is where the culture says, because I'm not saying it here. Just a minute. As you can see, what I have written is that is a culture. Because by listening to my thoughts and process, definitely it will not open any window. It will not open any door for you to get your job. Definitely that is the target. Why I have come to do my BTech. For the newcomers, what I mean to say. Because I have to start my career. This is my professional degree. Competition, it was there, it will be there, it is there now, and it will be remaining. There will be always. When we joined BTech in this particular department, a lot of people, a lot of my friends, one of my friends is now my wife, everybody thought that, yes, we'll have to get a job. Yes, that is a prime importance. But to get a job and sustain there, which I believe is more important than getting a job. Job will be there. It will come. You can believe on luck. You can believe on your merit. You can have that confidence. You will get the job. But to sustain with the job, you have to like it. So that is where it says the Latin word colere. It comes from the word of the culture. So we have a culture which has come from my family, from my home, from my parents, from my teachers, from my professors, and that culture has shown the behavior through which we are passing, the way I react. When I see a tree, if I have a poetic culture, I will see the tree and describe it as in a poetic version. When you are an engineer or a technologist, you will be looking into that tree with a different view. You will be seeing the dome shape, you might be seeing the umbrella shape, you might be seeing the conical shape. Why it is conical? You will start digging that. So what I mean to say is that our teachers in this professional department, the degree we get it, what we learn not only the engineering, we learn how to develop our analytical brain. The brain is always there, but we try to build it up, we develop it. When you ask a question to a science graduate, you will get certain answer. But when you ask the same question to an engineering or a technology graduate, you will get a different answer. And that is the difference. When the new entrants in my service career, they used to come and we used to interact with them across my table. I used to ask them, what you are? I'm electrical engineer. What you are? I'm a chemical engineer. Okay, fine. What you have learned in your college? Everybody, some of them just were numb. They couldn't answer properly. Some of them, they started telling the syllabus. I said, sorry. You have learned how analytically you will face the situation when you face it. Because everything cannot be taught within the four walls of this building. You'll have to see it. So that is where the culture comes into. So you will develop a culture in this particular institution. And once you go into the organization, there will be a definitely culture. Now my intention of this particular slide or this particular theme, which I thought to be very prudent, is that to give you a slight hint, though there is no hard and fast rule what is this and what is that, to understand the culture, what type of culture. Now I will not read the slides. The slides will be available, as sir has very well said, in the website whenever you require. This can be loaded so that you can refer it whenever you require it. But you must know what to find where. Those are the things were taught by our professors. You will be also listening and doing the same thing. You must know where to find where, what to find where, which book or which Google string I should type to get our information. That is the analytical brain it gives. Now Google is there, it's very helpful, but don't believe everything. थोड़ा समझ लीजिए, लेकिन उसका पहले थोड़ा टटोल लीजिए, जो आजकल अमिताभ बच्चन बोलते रहता है ना, वही बात है, थोड़ा टटोल लीजिएगा. But anyway, so these will be there. So different types of organizational cultures are available. The management gurus and other things. So they are our adhocracy culture, clan culture, hierarchical culture, market culture. Now what are these? These are the major four. Slide has not changed. What do I do? Okay. I think that will be better. Wait, give me a minute. Right. Okay, science করতে দাও. অনেকগুলো খোলা আছে না, that is the problem I believe. It is changing in the laptop, but it is not coming onto the screen. Should I stop the presentation and then reload it? Anyway, whatever they are trying to sort it out, my point of interaction is that we'll understand what is organizational culture, from where the organizational behavior will come up. And we'll have to align to that. You have a question? Please. You can throw it up now, or you can wait for the, say, my presentation to end, or whichever is your wish. Keep it in mind. You might walk. Sir. Yes, thank you. See, that is the analytical brain, it worked. I couldn't do it. Anyway, so the thing is that there are different cultures. Now you can see the advocacy culture. I don't want to give Gyan, but these will be there. But once you see the blue lines of which are the companies that follow it, the advocacy, I will say it is the opposite word of bureaucracy. So now we all understand what is bureaucracy. Now it is the advocacy. That means it is a collaborative type of culture. When you enter into an organization, you will have to understand what type of approach they have towards their employees and what are the benefits they are going to get it. Now here I will give you a small story. If you are always an yes man to your management, once you are into the company, you are no good. There are some managers, good, smart managers, they will give you everything and you will find he is an yes man. Okay, he is no good, he cannot take up the challenge. Some no's are required, but always negative, that is also not acceptable. So you will have to be very, very tactical. You will have to express your feelings by understanding what is the organizational culture you are facing with. You might be thrown out of the system if you are not aligned with that. So the companies, if I just quote, which are the companies? They do it, particularly Apple and Facebook, they go by the advocacy. So it is just the opposite of bureaucracy. Now coming to the clan culture, you may not be aware of what is clan culture. Clan, if I translate it into Bengali, it is called Bongsho, dynasty. The clan culture comes from there. The companies which follows the clan culture are, maybe best example is Twitter and Google. I have written that, tried to assimilate everything there within this particular slide. They are having some pros and cons. You don't need to remember it, but once you know what is this and what is that, then you can always correlate. Then there comes an hierarchical culture, which is very understandable. There is a hierarchy, there is a chain, the power comes down from the top to the bottom, which I have also worked onto that for type of oil and gas people, companies and large organizations. They are very stable companies. They follow the hierarchical culture. And then there is a market culture. Market culture goes into that, it is market based. So like GE and Tesla, Amazon, they are type of market-based culture. Next, I take it up that out of these four, from the scale, if you see the stability, flexibility, external focus, or the diffraction, those things, if you see, these are the four quadrants where they stay, just for an understanding. But my intention is coming in the next few slides. Other types of cultures are also available. They are the purpose culture, as it is written there, learning organization culture, enjoyment organizational culture. All these things are written in front of you. But mind that these cultures are mixed type of thing which can go and fit into the earlier four also. They can be learning culture. Here it is a learning culture in our department. We can somehow define it in that way. But these are the ways, and when we see into the flexibility quadrant, interdependence and dependence, in these quadrants they are there. So type of the authority or the safety, order, independence, all these things are there. So this is more or less the culture. So now coming to the main topic of aligning to an organizational behavior and culture, there is no straightforward rule to it. It is the intelligence, it is the presence of mind, it is the common sense, which is called to be a very rare sense, but that is the only sense. So there, these four topics, 4 lines, I could find it out from my experience, you can say, or from the different management guru books, that do your homework before joining, be open on early on. I have 1 slide each for them, and stay engaged over time, and fit into the new job and adapt to the company culture. Now coming into the do your homework. Nowadays we have the support of IT. There your LinkedIn, Facebook, Glassdoor, almost all the companies, they have their profile page. So you'll have to go to the LinkedIn, you registered yourself and read about the company as much as possible. Go to their website, read their vision, mission statement, what are their pros, cons, how CSR they are doing, everything. You should not leave anything about that company. Spend some quality time of maximum half an hour to 1 hour. You will understand and you will get the idea where you are going to join. Definitely, that is their showcase. They might show something more. And this presentation will be available in the website. You need not to take it, right? Then be open early on. What I mean to say is that in this particular case, don't hesitate to type brief note. When you start moving from one officer to the other in your executive development program, or when you have been sent for the getting conversant with the work culture to whom you should meet, not in front of the officer or the manager, you must take some note on your phone. Who is he? Firstly, his name should be properly taken down. What is his position? What he does? So, and whatever the takeaway points, you could take it out from him. This will help immensely to know about that person. If you happen to meet him in a social gathering, you can always interact with him and he will be, oh, he is good. So he has noticed me. So you will make your impression. So take a brief note on your phone. Generally, we used to supply a diary, which they are supposed to write, but it's a private diary. I have my own diary till now. When I joined in 1985 with Oil India Limited, and that time, whatever whom I have met, I had a note on them. So I could meet them, I can talk to them. Remember to be sociable and friendly. Do not be introvert. Do not be extrovert also, but try to mix socially. हाँ 10 बजे से 5 बजे तक काम किया, उसका बाद मैं घर गया, मैं और क्या चाहिए. But whenever there is a social gathering or official function, try to attend it and stay there. It might be boring, but you'll have to stay there to understand the culture. Otherwise, you may not be able to get soluble into that. You'll have to get yourself into the system. But never discuss any politics or any political question. Avoid those. You avoid those tactfully and do not show your belief or inclination, whatever everybody should have. Everybody has, particularly the people from Calcutta, they are very, very sensitive and they know this one. From Bengal, oh, you must be something, they will start talking. Well, yes, sir, there are something, but yes, I didn't have time. Try to tactfully avoid those situations. Initially, do not express what you know that better than the person you are sitting in front of. Your manager, do not, never show that I know better than you. Sir, this is the new technology, you don't know, you are backdated. Please, do not do that. No, sir, आप ही तो गुरु है, आप ही तो सिखाओगे. सीधा सीधी, तेल मारो. लेकिन ऐसा तेल मारो, ऑयल टेक्नोलॉजी बोलो चाहे जो भी बोलो, तेल ऐसा मारो कि उसको पता ना चले. ऐसा धीरे से, हल्का से, कि वो स्लिप होके गिर ना जाए. ज़्यादा तेल मारोगे तो उसको पता चल जाएगा ये मेरा लेग पुलिंग कर रहा है. Sorry, I am speaking Hindi also. Anyway, but when asked about your final year project, your dissertation, your project, whatever is that, तब जी फाड़ के उत्तर दो. You are the boss. You show your confidence that whatever I have done with confidence. That time he might ask, no, you have done something wrong. This is not the way. Maybe he is master. He has been doing that. Maybe some design, something has been done. Then you accept it politely. Do not contradict. Say, yes, sir. I'll tell you a story. One boy from IIT Guwahati, he's a mechanical engineer, came and joined in my department. He came to meet me. I was that time superintendent engineer. He is new entry. He came, met me. I'm fine, good. IIT Guwahati, they have a different stamp. I don't know. I have taken interviews with IIT. I have visited their faculty, but I have some little other reservation. Anyway, so he came. I asked him, what was your project in the final year? He said, sir, I designed a heavy-duty bicycle. Very good. What is the load carrying capacity? I asked, you designed for? You won't believe he couldn't answer. You won't believe he couldn't answer that what is the load carrying capacity he designed for his bicycle. Then I asked him, घर में दूध वाला आता है ना, तो उसका स्पोक मोटा कर दिया तो वो जा रहा 2 साइड में 2 कैन झुला के ले आता है, तो आपका डिजाइन कितना का है? Couldn't say anything. Why? I digged into it. Why he couldn't? He is an IIT graduate. Because he followed something where his analytical brain has not developed. Or he might have been timid to talk to me. He was afraid of talking to me. I don't know. So that is where I am saying, when project part is discussed, where you are confident, you will have to tell very confidently that we will show you your ability to communicate. Try to communicate properly. And when you find, on the contrary, that is the second paragraph under that particular heading, that some officer might be asking you some silly questions about your academic interest. ये formula क्या था? वो Avogadro number क्या था? वो Euler coefficient क्या था? He will try to show off that he knows better than you. Take a note in your phone, this fellow is not good. He wants to harass me. देखो भाई, it has to happen because 5 fingers are not equal, but everybody has a different purpose for it. I have to show thumbs up with this, I cannot show the thumbs up. So it has a purpose for it. So take a note about that. It happened. One of my engineer, he was very good in his job. He never used to come to my office from the field. During his particular off day, I used to tell them, come and visit, I will show you something, some calculation, some magazine I will give you, you will go through it. He never used to come. Again, I meet him in the field. Why you have not come? You are enjoying your this particular type of holiday. This is your learning stage. Then he said, you know that, sir, I don't want to come to your office. Why? Sir, next to your room, there is a person, Mr. Saikia, somebody. He is very, very dangerous person. Why? Now, he will definitely call in his room and he will start asking all these questions. Achha? So that is why you are afraid of coming to me. Well, yes. And then you do one thing. I am giving you one question. You go to him, sir, may I come in? Sir, एक चीज समझ में नहीं आ रहा है, डाउन होल का कुछ हम बताया था उसको रिगार्डिंग ड्रिलिंग, सर इसको कैसे सॉल्व करें, ये थोड़ा सर को पूछ लो, बस, और इसका उत्तर ये है, जाओ. एंड द नेक्स्ट डे ही केम एंड ही सेड, सर वो बोला है कि बाद में बोलेंगे और उसका बाद से कभी हमको देख के बुलाता भी नहीं है. And that is the point. You need to deal it tactfully. So these are the experience I am just sharing. Seeking out those who are well connected to the organization. In the organization there will be some people. In the class also there are some boys and girls. Some are very reactive. Some are good. It cannot be, everybody cannot be good. In the office also there are some people, अरे promotion तो मिल ही जाएगा, सैलरी तो मिल ही जाएगा, चलो कागज आएगा, कागज छोड़ेगा. तो उसका कोई अचीवमेंट का इच्छा भी नहीं है. हमारा एक मैनेजर ने बोला था, यू शुड डू दिस, यू शुड डू दैट, यू विल गेट मेडल. तो मेरा एक कोलीग बोला था, सर हमको मेडल भी नहीं चाहिए, दौड़ना भी नहीं चाहते हैं, वहीं पे बैठे रहेंगे. सो देयर आर पीपल, सो ट्राई टू आइडेंटिफाई देम. Try to be communicative with those people, those who are well connected in the organization. तेल मारो मत, लेकिन उन लोग का साथ में अच्छा रैपो रखो. बट ऐसा भी नहीं है कि उसका साथ में रैपो रखा तो ये हमारा गुस्सा हो रहा है, ये हमारा डायरेक्ट मैनेजर है. ये भी हम फेस किए हैं. I have faced certain situation that as because I am good to with somebody, Mr. A, Mr. B is annoyed with me. So this type of office politics always comes into place. आप अच्छे हो लेकिन आपका environment अच्छा नहीं है. So you have to be careful about that. So coming to the next is stay engaged over time. आप एक company join किए हो, but you don't like it. You immediately wants to change it. How long you should stay to understand? That is the point. विदाउट अंडरस्टैंडिंग आप कंपनी छोड़ के आ जाओगे, दूसरा कंपनी में नौकरी मिल गया, बेटर सैलरी मिल रहा है, घर का पास है, बाद में आप रिपेंट करोगे तो तेरी ये तो उससे तो वही अच्छा था, बट यू कैन नॉट गो बैक. सो स्टे एंगेज्ड फॉर सम टाइम. try to love your job. I'll give you another story to it. Do I have time? Sir, time kitna denge? It was half an hour, but okay, I'll finish it. Sorry, I might be eating his time, Mr. Tripathi's time, but I'll share a small story about it. You may like it. Regarding that, where is it? Stay engaged over time. The first day, in 1985, on 3rd of June, I landed in Assam. And I flown from Kolkata to Dibrugarh. That was my first flight in my life. I went there. I reached their office, reported. I didn't like it. And that particular day, the flight was delayed. And because of the turbulence, they have not served any breakfast. The flight was in the early morning at 5. It was via Guwahati. It landed in Guwahati. They served tea, biscuit, but they could not serve anything breakfast. It was Indian Airlines those days. Then from Guwahati it was waiting because of the bad weather. It reached there somehow around 1 o'clock in Dibrugarh. Somebody told the office closes at 3:30, so you'll have to join because that was my joining day on or before 3rd June. I was so callous that nobody told me that on or before 3rd June means you should go on 1st June and join. So on or before. So I read only on. Before I forgot because I never wanted to leave Kolkata. So anyway, so I went there and joined. The joining manager asked me, offered me biscuit and again tea. I still remember those were snacks, namkeen biscuit round. And there were about 6 to 8 biscuits on the particular plate, and there was a cup of tea served to me, and he was also having a cup of tea. But all 8 biscuits I took immediately. I ate them all. I never offered him. He was Major Vinod Krishna. He was ex-army man. He had a bullet injury, so he was a Tera man. Anyway, so he then asked me, see how he watched me. He said, you haven't your lunch? Oh, no, sir, I didn't have my lunch and I couldn't have my breakfast also. I'm only on tea and biscuit. Oh, should I get more biscuit? Oh, no, sir, enough of it. So after that, I took dinner at the last. So, and I never liked that place. That was my first day's experience. On the 4th day, I was sent to the site. I was in drilling. I have drilled 5.5 kilometers from the Mother Earth crust. Those are easy thing for me. I have done deviated drilling, I have done horizontal drilling. Those are the things I have learned over my career. Anyway, जब जानते हैं तो अच्छा है, जब नहीं जानते तो बहुत मुश्किल है. Anyway, so the first day I went there, we were a batch of 13 people, boys, and we were asked to get down from the bus, minibus. The first step I took onto the field, my leg went to the knee-deep mud. The first step, it was a slushy ground in the drilling site plinth. And I had to pull my boot from down below. Kahan aake pahuncha hai? Yes, I happened to be the first class first of BTech. Sir knows. Ghoshar called me, but I didn't expect. This is the job I have to do. This is the locality. कोई टिफिन नहीं है. सूखा हुआ चाना, भिगो के चाना वही पॉकेट में लेके जाते थे हॉस्टल से. This is the culture. But I had to love my job. There was nothing oil into it. I was from oil faculty, BTech oil. Mohua knows very. So there was no oil applicability there. Only oil, साहब लोग को थोड़ा तेल मारो, और कुछ नहीं था. So ultimately what I did, it was all mechanical. It was all, man management was there, but it was very less for us. So ultimately I started learning how clutch works. I remember our sir in mechanical in the workshop, GC Gopal Bhattacharya sir, I remember I had the Strength of Material, Timoshenko Young and other things, Shom series. I carried those books. I started reading them again. KNC, right, very well. So anyway, I will share that in some other time. So I started learning how the clutch system, where is the power drive, how the power flows, where will be the clutch, how will be the pinion, what will be the gear. All these things I started learning, and then I developed my interest into it. That is what I was telling. I didn't expect that I will be going up. But in that particular department, I joined as a graduate engineer trainee. And in 2016 end, production means a full field of about 1657 square kilometer area was given under me. Do whatever you like, give us oil and gas. You do the geology, you do drilling, you do production, whatever you do. So anyway, that was my responsibility given to me. So what I mean to say that those things I have not studied in my BTech. Even I came back for MTech in 93, 94. We did MTech here. That was my intention to switch over. But no, we stayed long, we stayed engaged there, and when I retired for 2 years, last 2 years, I have been the executive director of that company and managing the whole field. Anyway, so my point is that culture is just the thing to keep the workplace exciting. Workplace is there. You are the only person who is going. Workplace is not going to change. You will have to change yourself to see the interesting things here. Then only you will love it, work will also love it. Then it will give you the feedback, that you will get the feedback, and it has to be there. That is, take it from me. It has to be there. Slow learning is better. Next I am coming, fit to a new job and adapt to the company culture. But here the main thing is that be a good listener. Whenever your boss is telling something, be a good listener. Even your colleague is saying something, even your superior or junior, they are saying something, be a good listener. That doesn't mean you keep on listening. You listen, filter it, apply it, and then take a decision and go ahead. Identify and grab the opportunity to reveal your skill, but do not push to get the chance. I have seen a lot of engineers there. They always look for, how do I do it? Oh, sir, hum ye kaam kar do kya? Sir, main ye kar do kya? Don't do that. Job will come to you. You will have to find out that, okay, this opportunity, arey ye to tough hai. I remember Vivekananda saying, when you have two ways, finally you cannot decide, you will have two ways. One will be a difficult one will be the easy one. As per your perception, always select the tougher one, and that is the correct one. And I have seen it in my life. Believe me, it happens. I have applied it in my personal as well as my professional life. So, identify and grab the opportunity and do it. Jump into it, do it with dedication. थोड़ा ज्ञान ज़्यादा ही हो गया ना, थोड़ा छोड़ो. Build up and maintain your knowledge power. Nowadays, Google is there, Wikipedia is there, lot of books are available. Keep yourself updated. The job you are doing. Look, I am a BTech chemical technology graduate, MTech, as Sir has said, with my oil being the specialization, right? Where I ended up as a petroleum exploration expert. Executive director, I was managing geology, I was managing production, I was managing drilling, everything. Where from I learned it? Through my career. I kept myself knowledge. Thereafter, as Sir has said, presently I am a faculty to CMA. You know what is CMA? Cost Accountancy Management, that in that Waterloo Street, which is not CA, but the CMA nowadays they call it. In that intermediate course, chapter number 9, Operation Management and Strategic Management. I teach it for, this is my third consecutive year is over, next session will be coming very soon. I teach them. कहाँ से कहाँ क्या पढ़ा रहा हूँ. I have been visiting to the ICD, which is the CAG or the central government. अभी तो ED बहुत ज़्यादा चल रहा है. CAG भी आके कभी कभी ऑडिट करते हैं और वो लोग भी पकड़ते हैं. तो सीएजी का डायरेक्टर, डेप्यूटी डायरेक्टर लोग वहीं पे आके कुछ क्लास होता है, दैट इज द ट्रेनिंग सेंटर. I am giving lecture there on extractive industry auditing, how it can be done. In an international seminar, I delivered something other, EITI. Those were not my subject, but I kept on learning, understanding, and kept on delivering them. So those are the opportunities you have to grab and go ahead. And knowledge power has to be built up, and do whatever the job assigned to you with attachment and love, that I have been repeating. Love your job, it will definitely return with positive result. And believe me, yes, it happens. Have patience and keep your expectations within your limit. This is very important. You cannot expect to become a HOD of a particular department which you have joined by politics or by doing some other means. Please, please, please don't do that. You do it nicely. If I am asked to sweep this floor, I will take a jharu and sweep this floor, which definitely should make an impact by the watchers that, अच्छा ये तो बहुत अच्छा से झाड़ू देता है. वो जो एक फिल्म था ना, अतिथि कब आओगे, दबा दबा के झाड़ू मारते. So like that. So whatever you do it with passion so that you are noticed. But you don't show, look, I am doing it. Don't show that. So thereby, my thing is, last slide, enjoy your life. There will be stress. It was earlier there also, it is here also. So enjoy your life. Don't consider it to be very hard. Time will come and prove it. Keep yourself focused with whatever you do with your attitude and maintain the culture where you are going it. You have a very good culture. Thank you very much. I will take if you have any question. Thank you. First, may I know your name, please? Very good. So I have, because of the time shortage, I have not gone back. Is that the question finished, or you have some other things? Yeah, please. Can you take the mic, please? And repeat it for others. Hello? Yes. So what I could understand, you have two questions, right? First, you have wanted to ask what is the clan culture, what are the pros and cons and different cultures, right? That is point number one. Second question, you have asked that you have been given a project, because I'm trying to understand, I'm repeating for the audience also and for me also, that you have been given a project, you know you have done the best. Now, what is your question? I could not understand. That project you want to do it. Yeah. We can all understand. Good. Yes. Good. We got your point. Can I answer it now? Please sit down. You have anything more? Okay. Let me first finish this, then I will take more. Firstly, as you can see on the slide, to answer your question, the advocacy culture, clan culture, hierarchical culture, and market culture, I have not hopped on this particular slide because it is more of a textbook sort of slide, which is from the management book. You refer to this slide, there are something written in the reds where you can find the do's and pros and cons of that particular culture. I will not take the time for the benefit of others. Second point, what you have said, the yes man. Now everybody, if it is yes man, You ask this 5 fingers, say these are the 5 boys or girls, they are working. Now 5 persons are working. I want to say that, okay, he has to do a thumbs up. He has to also do a thumbs up. He also has to do a thumbs up. The job is thumbs up. Now, everybody said, sir, we can do it. Now the manager will think, how he can say that he can do it? He cannot do. So the manager will assess that he is an yes man of no use. Right? I am saying from the manager point of perspective. From individual perspective of a candidate, you will say, yes sir, I will do it. I will say, no, I cannot do it. Don't do that. Whatever the job is being given to you, every time you have to say, yes, I can do it. But if the boss asks you that, can you go to airport, Dum Dum airport, and bring my wife and take her to the big bazaar for some shopping, you see, I will have my card expired, so you use your card and drop him by. You will say yes? No. That is the point. That is the point. हम थोड़ा busy है. I have some colleagues. I had some colleagues. मैं थोड़ा busy हूँ. मेरा बेटा का थोड़ा homework करो दोगे? Yes sir. चला गया हो घर में. हाँ तुम बाजार जा रहे हो ना, बाजार से मेरे लिए 2 किलो आलू लेके आ गए थे, घर में कुछ भी नहीं है. These are the things the bosses will tell you. There are good bosses, bad bosses. They will tell you. So you have to say, अरे सर मेरा भी तो कार्ड एक्सपायर हो गया था. सर मेरा तो आज गाड़ी ब्रेक डाउन है, मैं एयरपोर्ट कैसे जाऊं? So tactfully you have to avoid those. That is the point I wanted to make. Right? Thank you. Thank you very much. I will take offline. I will talk to you.
Thank you, sir, for the inspiration and the informative session. I'm sure it will be very helpful to our students. Now we will take a break for 5 minutes at the most for changing the battery.
Well, as announced, we will take a break. But before that, let me thank Devgan for his beautiful speech. I was just sitting there listening to him and trying to remember those classes in which I taught a general subject to them, not oil technology as he was the specialist of which. But what he said is so interesting that I see the faces and eyes of the students and the many questioning faces. So there may be many questions. It reminds me of one Chhora poem. Almost all of you have read it. Premendra Mitra Boi Toi. Definitely you remember. Boi to poro, toi poro ki, tai to kati chhora, boi pora sob michei, যদি না হলো টই পড়া. তারপরে আরও আছে, সেগুলো তোমরা জানো, পড়েছো. তো এই যে এতক্ষণ ধরে দেবরঞ্জন যে কথাগুলি বলল, আজকে আমি বসে বসে শুনছিলাম, তাও ভাবছিলাম, who was a student of me, I taught him, but he taught me today. Some of the things, যেটা টই পড়ে অনেকে অনেক কিছু গোটা জীবন থেকে জানতে পারবে, হোয়াট ইজ টই, সেটা প্রেমেন্দ্র মিত্র যেমন বলেছেন, রবীন্দ্রনাথ তেমন বলেছেন, প্রফুল্লচন্দ্র বলেছেন. টই পড়াটা পড়ে যেও, সেটা পড়া বলতে শুধু বই ধরে পড়া না, এটা আরও অনেক কিছু, লাইফস এক্সপেরিয়েন্স. সো ইট ইজ এ লাইফ লং এক্সপেরিয়েন্স অ্যান্ড নলেজ গ্যাদারিং. থ্যাংক ইউ ভেরি মাচ.
Thank you, sir. We'll take a short break, 2 to 3 minutes for changing the battery.
না ঠিক আছে, আপনি ইয়ে করুন, আমি করে নিচ্ছি. ব্রেক নেওয়া, আমি জাস্ট একবার অফও করে দিতে পারি. আমি জাস্ট একবার কী হলো দেখি আবার নেক্সট লাগবে। হ্যাঁ ঠিক আছে, হয়ে যাবে। হ্যাঁ কি ফুল স্ক্রিনে? ফুল স্ক্রিনে তো পাওয়ার পয়েন্টে গেলে এখানে ইয়েতে চলে গেলে এখানে দিলেও নিয়ে নেবে। ওটা ঠিক আছে, আমি জাস্ট স্লাইডগুলো আছে কিনা একবার জাস্ট দেখে নিচ্ছি। কি? হ্যাঁ ঠিক আছে, যখন ইয়ে করবে আমি তখন শুরু করে দেবো। স্যার যখন এ বলবেন তখন শুরু করবো, আমি জাস্ট এটা দিয়ে রাখি।
Well, for some technical reasons, we have to continue this. And I therefore invite Dr. Himanshu Tripathi to come to the dais and speak on his subject. Acha. So a few moments gap there will be, and then he will be invited again.
Welcome back to the second part of our technical program. I would first like to request our chairman to please welcome our second speaker of the day, Professor Himanshu Shekhart Tripathi, for the felicitation. I would request Megha to please bring the bouquet.
Well, I invite Dr. Himanshu Shekhart Tripathi to deliver his lecture. I have already introduced him to you. So please, as I am told that these speakers have a time of about 30 minutes, so they will try to finish within approximately that time. I invite Dr. Tripathi.
Okay. Hello. So good afternoon, everybody. Just and first of all, I must thank our Chemical Technology Alumni Association for giving me this opportunity to share some of our work. This work is actually carried out by one of my PhD students. So and this is actually a R&D research work, and I will try to just simplify some of the findings so that all the peoples can understand. And this lecture is typically for our young friends. So this is the content of my talk. So I will give you a little introduction about the corrosion, and then particularly the refractory corrosion, and what are the testing methods that is typically used in the laboratory, in the industry. And then I will come to directly to the alumni program, how we have developed. We'll just skip some of the slides. I will request Professor Mojumdar just give me just about 5 minutes time before the dead. And then properties of the sintered block, I can skim some of the, and then corrosion behavior, how we evaluate the corrosion behavior of the refractory. So if you see the corrosion, what is the difference between the metal and the refractory corrosion? Metal, usually at the low temperature by the chemical reactions, with gas, liquid and salt. And so the oxidation of the metal to form some phases, which is then lost to the environment by spallation, by dissolution, or by some other mechanism, and resulting in the mass loss or in the formation of a surface layer which can have protective characteristics. But in refractory, this is the corrosion is the high temperature chemical reaction with molten metal, slag, salt and gas. So, high temperature corrosion of the refractory. So, corrosion of the refractory is a complex phenomenon. And if you see the refractory wear, so refractory wear is generally there are two types. One is physical, that is the erosion by means of erosion or by means of mechanical wear, and or chemical. So this chemical wear, that can be again the penetration or dissolution reaction. And corrosion, how we can define, how we can measure what is the corrosion rate and or quantify the results. So that means there is two way. One is the penetration. There is permeation of the liquid slag into the refractory line, how much it penetrates into the refractory. Or depth of corrosion. Depth of corrosion is actually the physical removal of the materials. So removal of the refractory lining by means of slag or liquid. Now if you see the typical ceramic microstructure, the first one, so if suppose it is a biphasic compound, there is two different phases, the clear grain boundary is visible, and there is no other pores or some other, so this sharp grain boundary, that means that the vitreous phase is less. But there is a second types of microstructure. This one is more or less the perfect microstructure, but in actual practice, when you are developing some refractory or ceramic material from natural materials, it contains the considerable amount of vitreous space, so the grain boundary is thick. And there is two phases, this blue and the green one, and suppose this grey color, these are the pores. So in actual practice, there will be some amount of porosity, and the other one, there may be some defects, some cracks, lamination, all these things. So if you see the microstructure, so this is ideal one, so this increasing the corrosion rate will increase from this side to that side. Because if there is some pores, then the infiltration will be more. So the first one can give you the better result with respect to the corrosion resistance. Now consider the pore size. So this is the particular refractory, the pore size is bigger. So pore size bigger means easy flow of the molten salt or molten slag, whatever may be, in liquid state. But if the pore size is smaller, then penetration will be less. Now it's just how the penetration rates, it depends on some of the factors. So this penetration rate is R square delta P by 8 eta L. So R particularly, this is suppose if this is a refractory and this is the slag zone and this is the hot phase, and then slag can penetrate up to a certain length, this is the L, and depending on this cold phase, depending on the temperature, if the viscosity is high, then ultimately it ceases flow at a certain distance. So this is the L, and then this L is the slag penetration depth, and it is the dynamic viscosity. And delta E, again it depends on the gamma rho cos theta by delta by R. So the slag surface tension, and theta is the working angle. So ultimately, so if you see the L, it depends on the radius of the force, and then the contact angles, and then the surface tension and the viscosity. So slag penetration can be suppressed by if you increase the slag viscosity, that is eta, or if you increase the contact angle and or decrease the surface tension. Now, for a typical acid-base reaction, even at the room temperature, so this acidity and basicity of a corrosion chemistry in ceramics at elevated temperature, acidic materials contains excess silica, typically. And over the basic metal, usually we use the term lime-silica ratio. When the lime-silica ratio, there is a CO by SiO2 is 1, so it is a baseline. So it is baseline is defined and the neutrality, lime-silica ratio is 1. If the lime content is more, it is basidic. If the silica content is more, then it will be acidic. So in actual practice, in steel lab, so instead of this pure lime and silica, we use the term CO, MgO, FeO, and then the top, and then silica P2O5Al23. There is a little bit acidic in nature. So this in actual practice, we use the term instead of pure lime and silica. So I can skip this slide. Now the molten slag or the glass viscosity is very much dependent on the temperature, and then penetration and refractory dissolution. If the viscosity is less, then the more fluid slag will penetrate more and likely to dissolve. See, if the liquid is penetrating more, that means the more surface area, the area that is in contact with the liquid and the refractory will be more, so that there will be more reactions. And suppose during dissolution, if there is some liquid phase and during dissolution it forms a phase having high viscosity, so it will be less penetration. If the viscosity of the end product is high, then viscosity high means less penetration, viscosity low means the higher penetration. So if the dissolving of the refractor in the liquid leads to increasing the viscosity, then mass transfer through the melt layer next to it will be the slower, and the melt layer becomes progressively saturated, and ultimately the corrosion resistance will improve. If the viscosity of the melt layer is decreased, if the viscosity is less, then penetration will be more, and more corrosion will be there. So in some cases, we intentionally use to increase the viscosity of the slag. If you can increase the viscosity of the slag, then automatically the penetration will be less, and then the corrosion resistance will improve. So now I'll come, suppose again in the refractory, suppose with the technical ceramics, almost there is no grains, only the fine pores is there. Suppose they sintered alumina. So this is alumina chrome. This is not just like a usual shaped refractory. This is a purely dense material having less than 0.5% porosity. So still there is some amount of closed pores is there or very fine pores is there. And if you just the dense refractory, and if you see the interface, can you see the interface? So this nice and clean interface. So apparently looks like there is no corrosion at all. So it is more or less the corrosion resistance. But in actual practice, if you just magnify it, you just observe it under the microscope, then you can see even from the elemental mapping. I will show you details in some of the slides. You see that this is actually the interface. This portion is the glass, this is the refractory, and you see that particularly this region, you see that the texture is different. So it looks like the porosity is more. So that means, but if you see the elemental mapping, this one is the alumina chrome, but you see that this one is the aluminum. So the aluminum concentration is less in this region. That means the aluminum ion is migrating from the refractory to the glass. But in case of, suppose if it is a brick or some standard refractory, so it is not a very dense material, the some amount of 12 to 14% porosity is there, unless it is a fusion cast refractory, then there may be some sorts of penetration. You see, suppose I just marked with the yellow color. This, if you put some alkali and heat it for some time at a particular temperature, so this is actually the infiltration of this. So at any point, in some cases, since there is a aggregate and grains and different size of grains, so you will not get a infiltration depth may not be a fixed, it will vary. And you have to take the infiltrated area instead of infiltration length. We can calculate the infiltrated area, and this is actually the wear out of the material by means of the chemical reaction. So bonded refractory, there is two stages. So with the bonded structure, there is bigger grains and bonded with the fine matrix. So initially this liquid, it just acts on the fine matrix, and then it dissolves the fine matrix and corroded the surface of the grains, you see. So this is the first stage, only the fine matrix is attacked by the liquid. And the second stage, the little bit the aggregate, smaller aggregate, and the bigger aggregate is corroded too much. And then in the third stage also, once the bond matrix is dissolved and some of the grains are corroded, and then it just wear out. So that effectively it is not a penetration, effectively you just wear out of the samples. Now the reaction and the temperature gradient. Suppose if it is a thin wall refractory, then what will happen? So if there is a step in temperature gradient, so particularly the thin film refractory, thin wall, so this side is the slag, and other if there is a cooling arrangement, so what will happen? Once the slag just penetrates to some extent, and then ultimately there will be a sharp temperature drop, and once this temperature is below the melting point of the slag, then ultimately the flow will cease at that point. So if the hot phase temperature is held just below the point where the product of the corrosion becomes liquid, the corrosion will be very low because it will not penetrate. And if the hot phase is maintained at no more than 20 degrees centigrade above the melting point, then it's called the lowest eutectic temperature. So there will be a reasonable corrosion. But if the temperature is more than 20 degrees centigrade above the eutectic temperature, the corrosion rate will be much, much higher. So now all together, whatever because we got this, sorry, I can skip this, yeah. So this, whatever the refractory corrosion, different test method is available in the literature, altogether there is 106 experimental setup. And they broadly classified into 12 main categories. But this is the most popular, this is the crucible test, this is all these things in the static condition, and these are the dynamic condition, this is rotating finger, crucible test, And this is a rotary drum test. This rotary drum test is typically this crucible test, and this rotating finger test. This is typically used in the laboratory. For a small sample, you can evaluate its corrosion behavior, but for industry, so this rotary drum test or the rotary test is useful. And it needs a bigger sample, just like a few part of the refractive brick, or maybe 40 millimeter by 160 or 180 millimeter in that. A little bit bigger size of sample is needed. And then how we characterize, after the corrosion, how we will characterize. So one is the profile measurement. Profile measurement means how much it penetrates or how much it corroded. And then phase changes, if there is any phase changes during the reaction, the chemical reaction, either in the slag side or in the refractive side. Or microstructural change, is there any microstructural changes, the compositional changes, and then there may be some cases, there may be some weight changes. So this is the rotary drum test. I will not just giving you these things. Rotary drum test, as I mentioned, small bar are lined inside the drum, and this drum is rotated with a particular slow speed with some angle, and you use the oxy LPG and oxy LPG flame, and then melt the steel and slag at a particular temperature, maybe 1650 to 1680 degrees centigrade at a particular area, and ratio is 10:1. This is a standard test. Maybe after few cycles, after 6 cycles, you open these things and mount it in a plaster of Paris and cut it, and then you can measure this, the area, how much it's just corroded. And then you can find out, you can compare the result with respect to a standard one. Now this is another one. This is a rotating finger. This one that can be utilized in the laboratory, and we have this facility. Here we have to do, because this is the total, suppose this glass or slag is kept in a crucible, and this is your sample, the standard sample, the refractive sample. If you want to measure this corrosion resistance in a particular type of melt, and this sample is rotated in clockwise, anti-clockwise direction, and there is some provision of some up and down movement. After some time, for a particular temperature, you keep the sample sometime, and then observe the main thing is that you have to observe the interface, what the reaction is going on, if there is any erosion. Okay, so I can skip some of these things. So now we'll come to my exact test, the alumina chrome. We have carried out this work just to develop the alumina chrome refractory that can withstand the corrosive action of the borosilicate glass. This borosilicate glass, I will show you the glass composition that is utilized for nuclear waste purification. So when you generate the high level nuclear waste, you have to it needs a proper disposal, and you have to vitrify in a glassy matrix so that it will not leach out, and then kept in a steel canister, and then there is some proper way for the nuclear waste disposal. So then why it is so important, the alumina chrome, why you have selected the alumina chrome? If you see the phase diagram, I am sure that most of the people, in the second year you have learned this, the phase diagram. So this phase diagram, you see there is no eutectic phase. Alumina and Cr2O3, it forms a complete solid solution over the entire composition range starting from the 0 to 100%. So there is no eutectic, that means there is no liquid phase formation at low temperature. And why this is not forming the low temperature eutectic? Because if you see the alumina and Cr2O3, they have the similar crystal structure, and this aluminum and chromium ion have the same charge 3+. And nearer ionic radius, since they have the nearer ionic radius, same crystal structure, and aluminum and Cr3 ions occupying the 2/3 of the available octahedral parts. Since due to the structural similarity, size similarity, and same charge, it forms a complete solution. It is ideal for the solid solution formation. So there is no eutectic form, and that's why if the typical property, the refractoriness is very high. So minimum is, because the alumina, if the pure alumina, it is 2050, and then 2200 something for Cr2O3, and chemical stability, it is quite stable, and corrosion resistance, particularly the low solubility in molten salt, glass, and slag. But there is limitation of this alumina chrome, because the alumina chrome is application in colored glass. You cannot use this chrome for some optical glass or some other glass, because the chromium ion can dip into the glass. Maybe if it is a small amount, that's colored the total. So this limited application in colored glass or fiberglass and all these things, you can do it. But the chrome bearing material, another thing is chrome bearing material is difficult to sinter. I will just give you one reason why it is difficult to sinter. And in some cases under oxidizing atmosphere, it forms a Cr+6, which is carcinogenic in nature. But so the typical application may be the waste vitrification, because our purpose is the nuclear waste vitrification, but that can be utilized for municipal waste, fly ash, industrial solid waste, all the vitrification and the immobilization of the nuclear waste. That is typically our purpose, is just to use this repository for immobilization of the high level nuclear waste. So this is a typically just any ceramic forming process. Since it is not a refractory brick, so we use the fine powders and we use the chemical grade materials, this alumina and Cr2O3, attrition milled, press it initially, and then also this material is isostatically pressed and then sintered at different temperature, even in the temperature of 1600 to 1700 degrees, and then we characterize different properties. I will skip some of the properties, maybe just not going into details. If someone is interested, maybe we can discuss later. So these are the starting materials, mainly this chemical grades, this alumina and Cr2O3. So these are some of the properties there. So we can skip all these things. And so these are the pure, this is interesting, just note it, because they have the similar crystal structure. If you see the X-ray diffraction pattern, only there is a little bit peak shift. Otherwise it is more or less same. The diffraction pattern is totally exactly same. Now, if you mix suppose in one cases we mix 1:1 molar ratio, 1 alumina, 1 Cr2O3. Then if you heat it at different temperature, even if it is 1000 degrees centigrade, 1300 degrees centigrade, you see both this one, this spherical is the corundum, this one is the escolite, this is Cr2O3 phase. So both the phases are present. That's why it's a 2 peaking at a particular temperature. So both phases are present. But starting from the 1400 degrees centigrade, little bit different phase is there. But from 1400 degrees centigrade, you see almost only single phase is there. So this is actually the solid solution of Al2O3 and Cr2O3. Now, even I will show you another one, because this result is needed, because when we just try to correlate the properties with the microstructure and of the alumina chrome. So instead of pure, if you start from the pure alumina, just add 10%, 20%, 30%, 40% and 50%, this mole percent. And then these are this is the pure alumina, and then 10% chromium oxide, 30% chromium oxide, 50% chromium oxide. So there will be a peak change. You see the peak is shifted towards the escolite side. So that means to the left and lower 2 theta angle. The escolite is to a lower 2 theta. And if you, from the Rietveld analysis, if you calculate the lattice parameter, it is a linear relation. So that means there is a perfectly ideal solid solution, and if you increase the Cr2O3 content, the lattice parameter will increase. So even from the measurement of the lattice parameter, we can have some idea whether it is pure alumina, whether it is pure Cr2O3, whether it is in between Cr2O3 and alumina. So it is a solid solution. So that will utilize. And now we have to sinter it. As I mentioned, why it is when we sinter this material, so this is a particular 1:1 composition. Even at 1650 degrees centigrade, you see the porosity level is 15%, although it is isostatically pressed, but still the porosity level is 15%, and maybe the BD is about 3.6 to 3.8. So these are the dotted, the solid line is actually in oxidizing atmosphere, in normal furnace atmosphere when you sintered it. But if you sinter this, but why we are getting this low porosity? Because when you sinter this metal in oxidizing atmosphere, this Cr2O3 there is a tendency to form to higher valent oxides, this tetravalent and hexavalent. And both the Cr2O3 or CrO2, they have a high vapor pressure. So since it is a high vapor pressure, at this temperature, it evaporates from the system, leaving behind the pores. So that it generates the in the oxidizing atmosphere, and then that's why it is difficult to sinter the metal in oxidizing atmosphere. But if you can maintain a oxygen deficient atmosphere, either it is reducing or in a neutral atmosphere or inert atmosphere, then you can easily densify this material. You see the same temperature when you use the reducing condition, the dotted one is reducing condition, the porosity level from 15 to reduced to without any other, all the parameter is same. The same sample, it shows the 5% porosity. Still it contains the 5% porosity. This porosity means the apparent porosity. So to improve the density further, we use some additive and then sinter it. So I can skip some of the slides, but you see the lot of porosity is there, even at the 1700 degrees, a lot of pores are there. So then to densify the metal, we use the titanium. 1, 2, 3% titanium, you used it. And you see then even with 1% titanium at 1600, even at 1600, and you see the porosity level is just near to 1% or the 0 to 1%. Even when we use only 1% titanium. And how this, so this titanium actually generates the vacancy. in whether it is in the aluminum or chromium, it generates the vacancy higher valence here, and that's why it favors the sintering. Now, even if 1, 2, 3, 4% titanium, there is only one single phase there. There is no other phase formation. That is also the titanium. It enters into the structure, crystal structure. It forms the vacancy and enters into the structure. Now, if you see the little bit strength, I will not go into details. Just things is titanium content. 1% titanium, it gives the better flexural strength at different temperature. And if you compare the hot hammer, if it is the hot hammer at 1200 degrees centigrade, why 1200? Because this high silicate, the borosilicate glass that is used at 1200, around 1200 degrees centigrade to immobilize the high level nuclear waste. So the application temperature is 1200. That's why we kept the temperature at 1200 degrees centigrade and evaluated its thermomechanical properties. So samples containing 1% titanium reveal the optimum flexural strength. And sintering temperature 1650, this is the sintering temperature. So since the sintering temperature 1650 gives the optimum strength and 1% titanium, we select this sample for the corrosion study. And these are the typical, so this is at 1600 centigrade, and I will skip. This one is a 1650 with 1% titanium. We have selected this sample for the evaluation of the corrosion behavior. 1700. Now you see, if we from electron microscopic, the photomicrograph, we use the image analysis software and to measure the grain size and then plotted the grain size. So this at 1650 with 1% titanium, this one is actually 1600, and this is without any additives, and then 1, 2, 3% TiO2. But this sample, you see the pattern, this grain size distribution, more uniform grain size distribution. That's why it gives the better properties. So sample containing 100% titanium have more uniform grain size distribution, which is related to the strength of the materials. So we select this material, and I can skip the same thing also for the thermal shock resistance. Also, this 1% titanium can give the better even the thermal shock resistance. Now, so this use the sample. So this is the typical properties of the refractory. So the bulk density is 4.45 to 4.5. Apparent porosity is huge. It is less than 0.5, 0.15 to 0.35. And densification 97 to 98%. Average grain size 5.5 microns. But glass density is 2.25 at 1200 degrees centigrade and viscosity 1.25. Now, how we have carried out the corrosion behavior? Now, initially, as I mentioned, this is a static condition. What do we have make? We make 2-inch cylindrical sample with 1-inch hole. 2-inch cylindrical sample with 1-inch hole, and depth is also more than about 1.5 inch. And then we kept some. This is the typical the glass composition that is used to immobilize the nuclear waste. This is because we have the technology at our CGCRA. We supply this glass nodules to the BRC. I think Mr. knows it very well. So this is the typical 5-component glass composition that is used to immobilize the nuclear waste. We melt kept this thing glass and melted at 1200 degrees centigrade for some time. Initially, this one is for 1 hour or 2 hours. Then again, you see the interface. Interface is a nice and clean interface. That is apparently there is no visible corrosion, but you see the under microscope there is a corroded zone. Now we will want to just in depth. So this is the schematic. This is the aluminochrome, and then you put the powder glass 1200 degrees centigrade. We heat it at 3 different temperatures. Initially 2 hours, 12 hours, and up to 36 hours. And then we cut into 2 halves, polish it, and then observe under the stereo microscope. Then we cut a small portion of the interface sample and then observe under the electron microscope. So these are the glass. Suppose this is the glass refractive interface. So the 2 hours, the corroded, this corrosion depth is, we measure this. You see this is the unreacted refractory. And this is the corroded region. Apparently looks the porosity is more, and the corroded depth is corrosion. This is the 85, although this is not a physical wear out. This is not a wear out, but the sample is there, but the compositional change is there. And when we just kept the sample for 12 hours, the depth is 267, and again 36 hour corrosion depth is 315. So initially, from 0 to 2 to 12 hours, there is a quite increase in the corrosion rate. Initially, although it is not a linear, and then with time it ceases, and then that's why at 36 AF there is not too much increase in the corrosion depth. And we just analyze these things. So it is not following a just linear. The equation is not linear, or in some cases, lot of the authors, they find out that it is a just parabolic equation. But we find out that even it is not a sub-parabolic also in our case. Now, why it is enough the series? Corrosion rate is ceases after 12 hours. Just we try to analyze in details. So then we have carried out we have taken a small sample, and from the interface, keeping the one side the glass and other side the small amount of refractory, keeping the corroded region is fixed, and then we measured the elemental concentration point analysis. Now we plotted the point analysis with this refractory. It contains aluminium, Cr2O3, and this side is the refractory. You see the sample one portion of the ACM photograph, and so this portion's atomic ratio 1:1. So this Cr2O3 and Al2O3, aluminium and chromium concentration is there, and this is a small amount of titanium is there. This blue, I think blue one is the Ti. This is actually a metal ion concentration, metal concentration, and you see that with and this is the glass side. So this chromium concentration is fixed, and chromium concentration is very low in almost zero in glass side. So that means chromium, this alumina chrome, the chromium is not diffusing, chromium is not participating in the reaction. So what is happening? But you see the aluminium concentration, aluminium Al, it continuously decreases throughout the length, this corroded region, and the concentration is much less near the glass. And the glass portion also contains some amount of aluminium. That means in uncorroded region, aluminium is there, the aluminium concentration decreases when it moves towards the glass. That means the aluminium is only leaching out from that refractory to the glass. And another interesting thing is, suppose this one, this as I mentioned, this silicon and sodium, it will be there, it will enter into the, because this borosilicate glass also it contains some sodium and silicon. But the iron oxide also enters into that. But suppose if the iron oxide may be present in the glass or maybe into the crystal structure. So, and the same thing, even after the 36 hours, you see that aluminum concentration is less, but the chromium, even after the 36 hours, the chromium, so that means the chromium is not participating in the chemical reaction, only the alumina chrome, only the aluminum component is just dissolves into the, or migrated into the glassy phase. And now, from elemental analysis, or if you want to do some mapping, then we have some idea. Suppose this one is the 36 hours. You see that this one is the chromium concentration is more or less constant, and this is the glass side, and absolutely there is no chromium in the glass. But in case of aluminium, this up to this portion, this is the refractory. But you see that in the corroded region, this aluminium concentration is much less. And near the uncorroded refractory, aluminum concentration is more, and near the glass side, aluminum concentration is less, but in glass, there is a aluminum. So that means aluminum is migrating from the refractory to the A. And then oxygen, titania, more or less it was there, it is not, in the glass side it is more, but the sodium is same, and you see the oxygen, titania, it is there. This iron, now interesting thing is, you see the iron in glass is more, because this borosilicate glass, it contains some iron oxide, and now this iron is migrating towards the refractory. Because even from the elemental, this particularly the elemental mapping, it will be difficult whether this iron is inside the structure or in the overall glassy phase. So now we have magnify the pictures, and then we analyze the individual grain, and I can go some of the spectrum. Suppose this is the glass, this zone 3 near the ear. If you start, this is the unreacted refractory. Zone 1 is near the unreacted refractory, and you move from zone 1, zone 2, and zone 3 towards the glass. Now this is the, suppose zone 1. Zone 1, you see the aluminum concentration is more. It is a point analysis of a particular grain. Aluminum concentration is more. But in zone 2, the aluminum concentration is much less. That means with the individual grain, this grain, this is the aluminum solid solution. Initially, if it is near this region, this aluminum concentration in that grains is less. And if you move towards the glassy phase, this glass region, this aluminum concentration is continuously decreasing. You see the peak, the concentration is less. That means that clearly indicates from the crystal structure, this aluminum chromium solid solution, aluminum ion is migrating. Now, This is a zone 3. Zone 3 is near the glassy phase. So if I am not showing you even in this is a point analysis of the particular grain, you see iron oxide content 6.47. So that means within the grain, iron oxide enters inside the grain. So that means the iron oxide forms the solid solution with that material. This iron oxide is not in the glassy phase. Suppose they were not. So if you see this particular grain, all the grains, you see that most of this grain, this white portion is black in the elemental mapping. That means the aluminum concentration is much less in that range. So there is dearth of aluminum, but this chromium is more or less this white portion. You see that chromium grain is there. Yes, suppose this grain, you see this is the grain. So chromium concentration is more, but here the same grain, if you see, aluminum concentration is almost nil. And see about the iron oxide. Even in the iron oxide, you see when the chromium is there, at that time, if we can magnify. So this iron oxide is when chromium is there, iron oxide is also there. So that means what happens? Initially, this is alumina chrome. Now this aluminum is migrating from the aluminum chrome solid solution, and the iron oxide is also similar type of structure. And then iron oxide, the iron enters into the crystal structure. So then how? So then zone 1, zone 2, zone 3 from point analysis of the individual grain. Point analysis on the individual grain. So this zone 1 is towards the unreacted refractory, and towards the unreacted refractory, atomic concentration, elemental, this percentage is 10.82, the aluminum concentration is more. When you move towards the glass, so it is 1.98 middle, and near the glass it is only 0.87. That means aluminum is continuously moving towards the glass. Now you see the interesting thing is iron oxide. Iron oxide near the glass region, this is not a glass, so 6.47, zone 2, 4.37 and 1.66. So based on these things, we propose this may be the reaction mechanism, how the corrosion takes place. When you use the alumina and Cr2O3, and when during the sintering process, it forms the alumina chrome solid solution. This is the first step. This reaction takes place during the sintering process. And then the initial corrosion, you have this aluminum AlCr2O3, and in presence of this Fe2O3, so this iron enters into the structure, ultimately FeAlCr2O3 type of structure can form. So this iron can replace some of the aluminum, and then free alumina, and then ultimately dissolves in the glassy phase. And ultimately at the final stage, instead of this iron, aluminum, chromium, this solid solution, it forms iron, chromium solid solution. So this final corrosion, the new layer is formed. And this, due to this new formation of the layer, it prevents the further migration of the aluminum. So this, then ultimately, this formation of this new layer seizes the corrosion. Now, how to justify it? So what we have done, we have taken a very thin sample, one just keeping the interface and one interface, and from one side we just take only the glassy side samples, and from the interface under optical microscope by careful removal of in few micron layers, we continuously remove it. So one side, this is the glassy phase. This is the glassy phase from the interface, and this is the crystalline phase, the refractive part from the interface, very thin layer. We remove the other portion, and then we have we studied the X-ray diffraction pattern. So you see this is the 0 unreacted refractory, and then after 12 hour, after 36 hour, and you cannot find any crystalline phase in the glassy. So there is no, suppose if the aluminum is, whatever the aluminum is coming from the alumina chrome, it reacts with the glassy phase and enters into the glassy structure. You cannot see any corundum or some other phases is there. But interesting thing is, before corrosion, because as I mentioned, it is a solid solution, even you see the before corrosion, so this is a diffraction peak, and after 12 hours, the peak is shifted towards the escolite, and even after 36 hours, it moves further. Now, from Rydberg defining, we measure the lattice parameter. Now we see the data, lattice parameter. So this alumina chrome refractory, before the test, 4.86. After 12 hours, it is 4.97, and this escolite is pure, this Cr2O3 is 4.96. So it is just, after 12 hours, it is just near to the escolite phase. But after 36 hours, 4.988, so it crossed the escolite phases, the lattice parameter, and moves towards the iron oxide. That clearly also indicates that iron oxide enters into the structure, and it forms ultimately the iron and Cr2O3 type of solid solution formation, and this actually seizes the corrosion rate. So I will come to the summary. Done. 2 minutes, or only 1 minute. Okay. So dense alumina chrome, we developed this thing in the temperature range 16 to 1700 degrees centigrade. And since 1% titanium gives a better strength, thermomechanical strength, and with uniform grain structure, that's why we select this sample for the corrosion study. And in all the sample, there is no visible corrosion, even after 36 hours. But the rate of corrosion does not follow any linear or subparabolic kinetics with time. And corrosion occurs by dissolution of alumina fraction from alumina chrome solid solution by the molten glass, followed by mass exchange. And Cr2O3 fraction remains uncorroded by the molten glass. Cr2O3 is not participating in that. And Al2O3 fraction in the alumina chrome solid solution is occupied by Fe2O3. And thereby, formation of Fe2O3, Cr2O3 solid solution. And this possibility, this layer acts as a barrier to molten glass, which seizes the corrosion rate. So these are the acknowledgement, because this work is carried out by my student, Dr. Mithun Nath, is presently as a VSUBS, and acknowledge the support from all the members of our refractory and traditional ceramics division. Thank you. Okay. Okay. Yeah. Okay, fine. You can close this. I will then take out the.
Sure, sir. I'll do that. Sir, I'll exit this one.
Sure. Done.
Yes, sir, it's done. Thank you very much, sir, for the informative session. We will now move towards the felicitation program, and I request our chairman to please felicitate our first speaker of the day, Mr. Devgan Banerjee. I request Megha for assistance. Mr. Devgan Banerjee. Chairman. Sorry. Megha, if you will please. Can we have a big hand, please? Thank you, sir. Our chairman will next felicitate our second speaker of the day, Professor Himanshu Shekhart Tripathi. Thank you, sir. I request our chairman to summarize the session and bring it to a close. Thank you.
Well, thank you all for giving a patient hearing to these speakers. And the second speaker, Dr. Tripathi. In fact, I will not summarize. Rather, I would make some concluding comments. Dr. Tripathi's lecture is a technical lecture. It is compact and, very hard with information on refractory melting by molten glasses. Now, I can correlate the two sessions, one by the former or first speaker and the latter one. Since we have in the department 4 sections, as you know, so this time there is a ceramic man speaking. Next time it may be oils and then petrochemicals, petroleum, refinery, and next time pharmaceuticals. These are technical lectures, but you can always correlate. As I mentioned, our history is a history of men and materials. The history of human beings is in a way, how you look at it, the utilization or processes of utilization of materials in different ages. We started from stone, then came to bronze, copper, then iron, and then metals, various, then polymers, ceramics, and then composites. Human beings are also subject to corrosion and erosion, and particularly at the high temperatures and high stresses, they become so typical, so technical, so complicated, it is very difficult to surmise, but we are also subjected to corrosion. And therefore, thank you very much. I think you can correlate. Thank you again for the patient hearing. And thank the speakers.
Thank you, sir. So this brings us to the end of the technical session. But before we proceed to the valedictory session, we have two important announcements for the alumni. The first is that we are planning an alumni get-together on the 4th of September, which is a Sunday, in celebration of Teachers' Day. And we cordially invite you to please bring your family along and please spread the word among friends, juniors, and seniors of the department. We look forward to meeting you there. And the second important announcement of the day is that the president of the Alumni Association of the Department of Chemical Technology will be announcing the logo of the Alumni Association. I request our treasurer to please help us with that.
Yeah. It is my privilege as a, yeah. It is my privilege to announce the name of that student who got this award really. That is Nandini Ghosh. Nandini Ghosh. Her specialization is pharmaceutical and fine chemicals. She is the 6th semester student of chemical technology, BTech. So this is the announcement, and we are all very proud of her for making such a nice logo, and congrats to you all. Yeah.
Thank you, sir. I just got this piece of information that we will be giving an award for this, for designing the logo on the 4th of September. So, with that, I would like to request the Secretary of the Alumni Association, Professor Deepa Biswas, to please deliver the vote of thanks.
At the end of the seminar is the time to offer vote of thanks. On behalf of Chemical Technology Alumni Association, I'd like to thank you all present here and also online for your participation and cooperation with us. I also like to thank the President of the session for being with us and for giving his valuable time. Thanks to the speakers of the day for their informative and interesting lecture. Thanks specially for giving their valuable time in spite of their busy schedule. Okay. Thanks to all the alumnus present here and also who are joining online for their participation and support to make the program a success. Thanks to the head of the department, the faculties, the staffs, the scholars, the students for their active participation. Thanks again to all.
Thank you, ma'am. So this officially brings our program to an end. We have arranged some refreshments at the exit. Thank you once again, all of you, for your presence, and we look forward to more pleasurable times together. Thank you very much.
সো সবাইকেই বলছি, স্টুডেন্টরা যারা আছো, অ্যালামনিরা যারা আছেন এবং যারা মানে ভার্চুয়ালি প্রেজেন্ট আছেন, সবাইকেই যে 4 সেপ্টেম্বর আমরা একটা খুব বড় গেট টুগেদার আশা করছি। সবাই আসলে আমরা ভীষণ খুশি হব, অবভিয়াসলি উইথ ফ্যামিলি, এবং কি যে মানে এটাতে পড়াশোনার কোনো কিছু থাকবে না, শুধুমাত্র আমরা আনন্দ করব সেদিন। যে যেরমভাবে পারেন পারফরমেন্স করে আমাদেরকে মানে আমরা সবাই মিলে একসাথে সেদিনকে খুব মজা করব, খাবো দাবো, পড়াশোনা কিছু থাকবে না। কাজে আমি সবাইকে রিকোয়েস্ট করছি, স্টুডেন্টস অ্যাজ ওয়েল এজ alumnis, to participate wholeheartedly on 4th of September at 5 o'clock. প্রোগ্রামটা ডিটেল প্রোগ্রাম উইল বি শেয়ার্ড লেটার, কিন্তু তার আগে জাস্ট ডেটটা সবাই ব্লক করে রাখুন যাতে অনেকে, এবং সানডে, ওটা সানডে, কাজেই সানডে, হ্যাঁ ওইটা একটা রবিবার সানডে, সেকেন্ড হাফে হবে, হ্যাঁ সানডে, সেজন্য সবাই যাতে ফ্রি থেকে আসতে পারেন সেটা এই রিকোয়েস্টটা আমরা সবাই ডিপার্টমেন্ট থেকে, অ্যালামনি অ্যাসোসিয়েশন থেকে সবাইকে রিকোয়েস্ট করে রাখলাম। ওকে, থ্যাংক ইউ ভেরি মাচ। ছবি 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 আমরা কি ওপরে দাঁড়াবো?
Hello, hello. Hello, hello.
hello. Microphone testing.
আবার একটা ছবি তুলতে হবে। এইখানে দাঁড়াও, ইউটিউবে দেখা যাচ্ছে।
Hello, hello, hello. আমরা হচ্ছি এক্সট্রা স্পেশাল স্পিকার।
আমরা হচ্ছে এক্সট্রা স্পেশাল স্পিকার। আমাদেরকে এলটি বালাজিতে দেখাবে।
আরে বন্ধু তো,
হ্যাঁ বন্ধু।
সুমিত ভাবি
গন্দি বাত।